Today we're gonna continue introducing more exciting features in the new releases. Okay, Ethan, take it away.
Yeah, thanks, Shian, for the introduction. Yeah, hey everyone, I'm Ethan. I'm a member of Hudi PMC. So today, let's continue. As Shian mentioned, let's continue looking at some of the important features we want to roll out. And actually, we planned for Hudi 1.1 release. So let me share my screen. Okay, give me one sec. Okay. So let's first go through the roadmap again. So last time we talked about some of the improvements around metadata table and the index abstraction. Today I want to talk more about some impactful changes around how we manage the core reader and writer and the surrounding integration support. So first, I want to talk about these new HFile writer we are introducing. So as you have already known, the Hoodies metadata table uses a different file format than Parquet file. Uses the format called HFile, which is a SS table format that can enable very fast point lookup. So we have these HFile format spec kind of mentioned in this HUDI module. Basically, we take this format from the HBase and we simplify it for the usage in MDT. So at the high level, HFile is structured as like a kind of a set of key value pairs and they are sorted. So and then the H file contains a block index so that whenever, let's say the reader wants to look for one particular key or set of particular keys, it can quickly identify which data block to read instead of scanning the whole file so that it can be faster by just looking for the specific entries to read. So in point 15, to actually integrate better with all these different query engines, including Trino, we introduced a Java-based HFile reader implementation in the Hudi repo, which is independent of HBase. Prior to that, we always use HBase reader and writer implementation. Even on 1.0 release, we also use the HBase HFile writer implementation. However, this approach, we see a couple of drawbacks. First, basically HBase writer it has a lot of configs, and sometimes it can be hard or complex for user to configure. Second is it incurs a lot of dependency conflicts in different, let's say, data systems. And it also increases the bundle size because HBase itself doesn't provide like a independent module for HFile format. It's kind of embedded or coupled with all of this HBase client, HBase server, etc. We have to include all of those dependencies. So that bloated the Hudi bundle jars a lot. So to solve that problem, in 1.1, basically, for this particular entry, we are introducing new HFile, a native HFile writer implementation in Java, and we completely removed the H-based dependency. So as of now, on Hudi master, this is already done. So if you build the bundle jars or like the Hudi common jars or Hudi Hadoop common jars from master, you see that H-based dependencies are completely removed. These actually reduces the bundle size a lot by like 20 to 30 MB. So this not only gives size benefit, but also it kind of removes any kind of conflict introduced by H-based dependency. So at high level, what we did is we pretty much follow like similar writer logic as HBase, and then we plug the new HFile writer in different places Hudi uses, including the HFile bootstrap index, and of course the MDT, the metadata table writer, and different other places where we use HFile writer. So this is the high level. So we also did benchmarks. We see that this HFile writer is on par with existing HBase based HFile writer. So we make it default in Hudi 1.1 release. So going forward, we are going to maintain this um, like Hudi independent like or Hudi native HFile writer. So that is also going to be easier for other language bindings like Rust, Python to follow this Java implementation as a reference implementation.
Nice. That's really cool. I remember there was a lot of in the past versions there are a lot of like in the Maven POM file there used to be a lot of exclusion from like the edge-based dependency related dependency to just make sure things don't clash.
Yeah.
But now it's getting much cleaner. Could you share a bit more like why do we choose HFile as the format for a metadata table?
Yes. So one of the requirement in metadata table, let's say for index like column stats or record index is that we need this needle in a haystack types of query or lookup. Let's say if we want to look for the column stats for one column among, let's say, like 1,000 columns in a table. Or let's say we want to look up the location of one record key among, let's say, millions or billions of record keys in a table. We want the metadata table to scan as less data as possible, meaning that let's say when we read the metadata table, we just want to get the information of that one particular record key or the information or the column sets, let's say min max of that particular column out instead of scanning the whole underlying file. So that's why we choose HFile. The benefit of HFile is that all of these key value pairs are organized into like chunks or blocks, as you can see here. So each data blocks you can contain like a set of key value pairs, and then we can control the size of this data block. So by default, we try to make it like let's say 1 B or a few MB. In that case, like this whole H file can be pretty big, let's say 50 MB or 100 MB. But if we just want to get one record key or like the column stats for one column, usually it's very small. So it should fit into one data block. Then what we want is we just want to scan that one data block to reduce the I/O cost. So the good thing about HFile is that it organizes these key value pairs entries into data blocks. They also sort it based on the keys. And then they store, so the HFile has like a block index stored in the metadata section. So that basically whenever you want to look up the key, you can first look at the index, figure out which data block to scan. Then it can only read that data block out and then figure out the information needed. This is better than Parquet in this particular use case because for Parquet, like usually you have to have like a large page and then it's column based. Here, we always want to read the whole like meta information. We don't have like the requirement of pruning based on like fields. So that's why we choose HFile because this is kind of the de facto format for like fast point lookup. Since it's also designed by HBase and then you use this kind of SS table form file format, it naturally provide like a good performance on this point lookup. So that's kind of the motivation behind why MDT or metadata table uses HFile format.
Right, right. That make a lot of sense. So actually, if you think about it, metadata itself is really about serving as an index for the whole table.
Correct.
And the query pattern, the way to query the metadata table is always like trying to look up something. Then this
Mm,
perfectly fits the purpose. Cool, cool. Yeah, thanks for clarifying. Yeah.
cool. So yeah, so we are basically since we are making so right now basically after we introduce this H file writer, basically both the H file reader and writer is under like Hudi's control. That's why we remove H-based dependency, and then going forward we're going to maintain this so that let's say in the future we want to do more optimizations like caching or reusing readers, then we can have even like the L level control in these read and writers, which is like another advantage we have.
Right. Cool.
Cool. So that's the first thing I want to mention. So next one I want to talk about this the engine integration. So in Hudi 1.1 we plan to add a Spark 4.0 support. Basically, the official Spark 4.0 release is recently out. Um, so for Hudi, we want to also onboard like the support for new Spark version. So there's already a draft PR out. Like we have been, I think the community has been actively working on this and then discussing the integration. There are so Spark 4 introduced a few new features like wide variant data type support for JSON-like data. And it also introduces more like kind of error handling, categorization, and other improvements in terms of the data support. So it kind of is different from how we integrate Spark 3.x release lines. So right now it is taking some time to get there. But along the way, basically we also clean up a lot of complexity in the Hudi Spark integration. So that's a good thing. So we expect that this Spark 4 support is to be landed in Hudi 1.1 release so that basically user can also use Hudi on Spark 4. And since Spark 4 supports Java 17 by default, so to support this Hudi Spark 4 integration, we are going to make Java 17 the default compilation for Spark 4 so that we gain all of the performance benefit from it.
Oh, nice, nice. That's like a major upgrade for this main dependency.
Yeah,
Java 17, Spark 4, yeah, all good stuff.
cool. So next I'll talk about um, two more core changes. So last time we talked about the file group reader integration with metadata table and the improvements around payload. So in terms of this interface to user for providing the custom merging logic, let's say for updates and MR table, remember in 1.0 release, we introduced these record mergers and built-in merge modes. So we have three merge modes right now. We have commit time ordering merge mode, which follows the order when the data is actually committed to the table. And the event time ordering, which follows like the streaming like um, capability that handles out of order events. And the ordering is actually based on the ordering field or the like timestamp or event time. And the third mode is custom, where user can define their own merging logic. And in 1.0, we make this backwards compatible that we still allow, let's say if user is on 0.x table, after they upgrade to 1.0, if they have their own custom payload implementation to decide how to, let's say, update their own data, they can still use the custom payload implementation, where it's like a fallback mode in this custom merge mode. And in 1.0 in Hudi, we also provide a lot of built-in payload implementation. Those are still kind of there, like because we want to support backwards compatibility. So in 1.1, what we are going to simplify is that we are going to gradually deprecate the payload interface. So we still allow custom payload implementation user provides. But in the Hudi repo, for all the built-in payload implementation, we are going to deprecate or remove all of them. And we are going to migrate the logic to either built-in merge mode, let's say event time uh, based ordering, or like a custom merger. So if you look at, let's say, one of the major use case, like the CDC payloads, so we have this Postgres DBZM's payload which support this change data capture kind of workload. If you look at the actual logic, it follows the event time ordering because it naturally has the like the let's say the sequence number to determine the order. So we want to actually migrate this CDC payload to use the event time ordering with some customization. That is something we're working on. Um, the reason we want to migrate these payloads to like built-in merge mode is that uh, this new built-in merge mode not only support existing like full record merging or updates, it also supports the new partial update using the new partial encoding in the log files. So that MR with this partial update encoding can have like much better performance on both the writer and reader side. So if we migrate CDC to from the payload to the built-in merge mode, then it automatically gets the benefit of the new partial update performance. So that is the main kind of motivation behind this new feature or new line of work where we want to migrate of these existing built-in payloads to like the built-in merge mode and then solidify like the write and read paths to go through like the let's say the new merge logic. So the new merge mode based logic is built inside the file group reader. So we are going to maintain that going forward. So right now, this work is still being actively working on. So we have more updates probably in the next month sync on like how this pans out. So this is basically the story of deprecating payload and support CDC with built-in merge mode. As I mentioned, we also want to support CDC with partial updates. So once we migrate this to event time ordering, then it should automatically get the partial update support. The only caveat or the only additional capability that this may require is for Postgres CDC type of workload or Postgres DBZM CDC workload. It supports partial update or change column per record, meaning that each record can have different set of change columns. Whereas for the current partial update support for Spark merging tool, we like the set of change column is always the same for all the record in the same batch. So to support this record level partial update for CDC, we are going to expand the table format, or at least the flow or interface within Hudi to make sure that okay, in the same batch we also allow different set of change columns. So these requires expanding the existing log format to support or existing log format, existing partial update encoding to support this kind of workload.
Cool. Well, yeah, I think that's pretty useful. So it's like it's very common in this, for example, Postgres CDC, DBZN stream that the change column is kind of different than ingestion when we take some like batch by batch or even for like micro batch to
Mm,
take it can be very likely the change is like the column change is different.
mm,
So this is like very kind of important support for ingesting from Postgres.
right.
Yeah. Cool, cool.
Yeah, so
Um,
basically this is also in the storage engine part because we want
yeah,
to expand the format.
yeah,
So stay tuned for more changes. So these we are going to first have like a POC in the next couple of weeks, and then we'll do some benchmarking on how it looks like before we can solidify like the format change.
yeah. And actually, right now, when people are using, I think people are already using Postgres with DBZN, right?
Yeah.
When they are emitting this, they're expecting to set like the full record change for each like change on the Postgres. Is
Yeah.
that
Yes.
right?
So right now it's full. Right now, even let's say if on the Postgres it changes like a subset of columns, the
Yeah,
change logs still contain the full record by
yeah,
default. So that Hudi can take that full record and then do upsert into the Hudi table.
right. I think
Um,
yeah, I think
yeah,
this will make things like much more lean in terms of ingestion volume. You don't need the whole record, you just need like some changed column. Like that's
correct.
for white table is gonna be like just a fraction of the incoming data to process.
Yes. And DBZM itself allows let's say the change log to say, okay, what are the columns actually changed. So
Yeah,
we don't even have to, let's say, derive that on the fly. So we can just rely on DBZM to emit that information. And
right.
you point out a good aspect that yeah, mostly in production, people may have like a very wide table they ingest from multiple sources to observe the information like for like a very small subset of columns for one record. And that actually that's why we have this partial update support encoding in log format in MR because this naturally solves the problem of wide table updates or partial updates.
Yeah,
So, and then we have already known some Hudi user they pick this up and they see good improvements. So we are actually pushing this feature to the next level by supporting CDC as well.
yeah. Nice, nice. Yeah, it's like very natural step. Since 1.0 we introduced partial update. Now it's time to profit from this like great feature by
Yeah.
improving the payload and in like improving the payload ingestion to make use of it. So yeah, that's a really good like the following step.
Yeah,
Cool, cool.
exactly.
I have a question on that commit. ordering versus event time ordering. So
Mm,
I know like from old versions, we have been introducing this pre-combined field.
mm,
So if you have table to upsert, you need to specify the pre-combined field.
mm.
So by setting that, that's actually already event time ordering, right? And now in 1.0, we kind of make this like optional. So people can omit that and just then Hudi ingestion will take just the commit time, like fall back to commit time.
Yeah, so correct. So we introduced this merge mode to make it simpler for users to understand because sometimes user may get confused about what this precombined field is if they only want the, let's say, because most people they have like simple use case or they have like a batch ingestion job where there's only one single writer. They don't have to handle like out of order or there's no concept of time. So to support this kind of workload, yeah, by default, the ordering is commit time ordering. And if they do want to dedupe, we still have this backwards compatible config like this pre-combined field where they can set so that dedupe can happen based on this. And across batches, then it uses the commit time for decide which record actually to use for the latest snapshot.
Okay, sounds good. All right. Yeah. Any other question from the audience? Okay. Is that the last point you'd like to cover today?
Yeah, so that's the main four things I want to cover today. I think I can go over some of the rest things that are also interesting.
Sure.
So yeah, so we are also introducing two more indexes in Hudi 1.1 release. And uh, so as already mentioned, like I think the RPC is also discussed in the previous DevSync meeting. We are introducing this bitmap index to accelerate the query performance. Basically, we are going to build bitmaps on top of columns for each file so that we can use bitmap to do like a map, uh, like a bit end on the bitmaps to actually filter rows, um, and then make the like data skipping more efficient. Another index we are going to introduce is the vector search index. This is to support kind of the vector embedding use cases where a user can build like a vector index based on a particular, let's say, text column. These are the new indexes we are going to introduce. Other things that are uh, important is we are also doing more code cleanups and refactoring around core abstractions like engine integration. I already mentioned around Spark integration. And then the file group reader improvements to make it more reliable and robust. And we are unifying the file group reader usage on Flink as well, so that Flink can get the performance benefit using file group reader and get the logic unified. Other things include better support for Presto and Trino Hudi connectors. So we have been actively working on like integrating Hudi 1.0 in Trino Hudi connectors. So actually since the Trino 4.7.4 release, it uses the Hudi 1.0.2 release as the dependency. So it supports both 0.x and 1.0 tables for COW and MR read optimized queries. Right now, we are upstreaming the kind of the metadata table-based file listing support in the Hudi connector and other index-based data skipping with some of the recent performance improvements where we are adding in the Trino connector. So Trino Hudi users should expect more performance boosts in the connector. And meanwhile, we are also adding the same improvements to the Presto Hudi connector. So we plan to have some improvements and some features landed by the end of Q2, basically this by the end of this month. And then sometime in Q3, we'll bridge up the performance and feature gaps in the open source Presto and Trino.
Nice, nice. That's all very important improvements. I know a lot of users are waiting, eagerly waiting for this to be landed.
Mm.
Awesome. Uh, Great. I think that wraps up our session today. Thank you again, Ethan, for your like helpful insights and sharing all these cool features. And thank you for attending. Have a great rest of the day.
Yeah,
Bye.
thanks. Thanks everyone. Bye.